In chapter R.6, we are going to discuss simplifying expressions. Now, in any math book that you get, this one included, it will always discuss simplifying expressions in about 4 to 5 pages of blah, blah, blah. But really what it all boils down to is two things. First, we will distribute, as we learned in the last video. And then we will combine like terms. And so you need to know a little bit about what like terms are before you can combine them, and then again, what are the rules of combining, and that's what this video is all about. Simply put, combining like terms is taking a whole math expression, like say 3x plus 2 plus 5x 3, and taking the terms that have the like variables, and even when they have variables, if those variables have exponents on them, then you have to look at the exponents. In this case, we have 3x is a term that has a variable with it, and then we also have a positive 5x as a term that has a variable with it. Aside from that, in this particular expression, we have a positive 2 and a positive 3. So combining like terms is really just the process of taking those like terms, putting them together, and then simplifying. So because I have 3 of something, 3 x's, and 5 of something, 5 x's, so let's say they're apples, 3 apples plus 5 apples more, that'll give me a grand total of 8 apples. Whereas if I have 2 of something else and 3 of something else, 2 plus 3 is 5. Now when you notice that this expression, because I now have a variable term, my x, and then I have a constant term, my 5, so 8x's plus 5, because they're not like terms, I can't combine them anymore. So this expression is simplified. Let's try 2 more quick examples of what it looks like just to combine the like terms, just to do this part of it. In this case, we have 5 x's, and we want to subtract from that 5 x's 12 more x's. And your book kind of does a little thing where it asks you to undistribute, or to factor out your coefficients. The coefficient is the number being multiplied by the variable. So it notices that both of these terms have an x, so it factors out the x and says basically what is 5 minus 12, and then we'll multiply that by the x. Well, 5 minus 12 is, if you take a number line and you start on 5 and you go in that direction 12 times, you're going to end up at negative 7. So we have negative 7 times x, and that's simplified in that case. Let's take a look at some fractions here. What if we were to have an expression that said 2/3 of x minus 3/4 of y plus 4/5 of x minus 5/6 of y, and then add to that 23? Well, again, because we have like terms, we can look at those individually. So I have 2/3 of x, and then I have this other x term here, so I'm going to add to that 4/5 of x. And then my y terms are minus 3/4 of y, and then minus 5/6 of y. And then at the end of the whole thing, I will have plus 23. Quick question. What is the property of real numbers that allows me to move these around like that? I'll let you put that into your lecture notes. But for now, what we have to do is we have to add these together. And we can't currently because they don't have least common denominators. Let's get rid of that and say denominators. So let's take a look at my yellow terms here, my x terms. The denominators for my x terms are 3 and 5. Both of those are prime numbers, so all I really need to do is multiply, and that'll get me the least common denominator. So the least common denominator for my x terms is 15. The least common denominators for my y terms, 4 and 6. Now I could just multiply those together, but I have another little trick I'd like to try. See, these have actually a factor in common even before we get started. So let's see what that factor is. I can ask myself, well, what's the smallest prime number that I can divide out of both of these terms? And as it turns out, both of them are even numbers, so I can divide them both by 2. And what happens when I do that? 4 divides by 2 times, and 6 divides by 2 3 times. And then I'll ask myself again, what is the smallest prime number that I can divide out of these two numbers? And in fact, there isn't one. I can't divide out anything more. So the only number they have in common is 1. Interesting thing happens here. This number out here, that is the greatest common factor. That's the number that I can divide out of both 4 and 6. In this case, 2. We're going to play around with a lot more of this later. So I can take my greatest common factor, and if I were to multiply that by this last row here, what I'm going to call the leftovers, if I multiply that by the leftovers, then I'm going to have my least common multiple. So in this case, what I've got is 2 times 1 times 2 times 3, or 2 times 2 is 4 times 3 is 12. 12 is the least common multiple between 4 and 6. All right. So using my 15, in order to get a 15 x's plus 15th x's here also. So here I have 3 as a denominator. In order to get 15 from 3, I'm going to need to multiply it by a factor of 1, 5 over 5, right? Any number divides by itself is 1, so I don't change the value of my fraction here. It's still 2/3. But now when I look at it, instead of saying 2 over 3, what I'm going to say is 5 times 2 is 10 over 5 times 3 is 15. That's still the same ratio. So 10/15 is an equivalent fraction to 2/3. And then the same for over here. I need to multiply that by 3 over 3. 4 times 3 is 12 over 5 times 3 is 15. And now that I have a common denominator, I can add those two. So let's see what that looks like for my y's. I have 4 and 6. We said our common denominator was 12. So how do I get 4? How do I make that become 12ths? Let's see. Well, 4 times 3 is 12. And we've actually got that here. 4 times 3 is 12. So that's good. 4 times 3 is 12. That becomes 9 over 12 y's. And 6 times what is 12? Well, again, 6 times 2, that gives us our common denominator. So 6 times 2 and 5 times 2, so that'll be 10/12 of y there. And to that, we're going to add our 23 still. So now it becomes easy. If we can add, and then if we have any reducing we can do, we'll do that then. For the first part, it looks like 10 plus 12 is 22. So we have 22/15 of x. And then negative 9 minus 10. So I owe $9. I borrow $10 more. So that's a negative 19 over 12 y. And since I can't, those are x's, these are y's, I can't add anything more to it, then we'll just have to say then that's plus 23. And this is now simplified as far as I can get it.